This is a CNCF cross-cloud CI project, and deep dive is going into one component, the cross-cloud provisioner. We had an intro yesterday. If you missed it, you can check that out when the recordings are up. So I'm Taylor Carpenter, and this is Denver Williams.
Hi.
We're going to be looking at what is cross-cloud, the provisioner itself, the goals of that particular component, the audience that we're trying to target, give a little live demo of that piece, technology overview, and code overview. That'll go into the GitHub code a little bit, how you can collaborate, Q&A, and maybe a little bit more after. So what is it? This is a multi-cloud Kubernetes provisioner, and it deploys vanilla Kubernetes to public and private clouds, bare metal. We can turn on cloud-specific features, and we can optionally run conformance test or test with the profiles or other things like that against those clusters. So our goal is to have a vendor-neutral, community-maintained solution that anyone could use to do end-to-end testing and deploy Kubernetes clusters for public, private clouds like OpenStack, and then test the interoperability. So who's going to want to use this? This is going to be folks who want to install their own Kubernetes clusters. That may be they have private clouds on OpenStack. They have a lot of different public clouds, maybe something that's not supported by existing technology. Right now, we're very much tied into the CI side, so ephemeral, knowing the state, being able to drop it quickly, and not having to maintain all those different cloud providers. With that, why don't we take a quick look at how this works, and then we can get into the tech a bit. Ready, Denver?
Yep. So where we are right now is we're inside a Docker container, so I can jump out of this quickly. And this is the Git repo cross-cloud, and in here's a Docker file that we use to produce an image called CNCF. And basically, this Docker run is going to pass in an env file, and that mainly contains cloud secrets, so AWS secrets, Google Cloud secrets. And then if we run that, we jump in here, and this directory is where all the main code is, and up the top here you have these directories matching the cloud name, Azure, GCE, and then you have templates down the bottom. So the directories that have the cloud name there, that's the cloud resource specifications for creating the virtual machines, security groups, and then the templates below is the cloud init data. So every cloud provider that we're using supports cloud init. So it made sense to use that. That way we have this agnostic template that it doesn't matter what provider we're on, we just feed it in and it provisions the cluster and brings it up for us. So we're going to run this on GCE if we cd into that directory. Here we have this input file. This specifies the variables of what should the pod CIDR be, what should the service CIDR be, and what artifacts are we using here. Right now we're using the default upstream 110, but when we're leveraging in our CI system, we actually override these with binaries we've compiled ourselves. So, and there's also another interesting file in here called modules.tf. And this basically pulls in the variables in that input file, and there's different sections. So there's, if we scroll up a bit, we have this section here for the worker templates, and what this does is it goes, passes in those variables and goes what cloud provider, pod cider, and the output of this module is cloud init data that's been rendered to configure the worker node. And there's another identical section in here for the master nodes. And then up above, we have the same identical sections for certificate generation and the actual VM creation. So to actually run this, we can go run a Terraform init, and this initializes all those declared Terraform resources. And then the last step is to run a Terraform apply. And that'll go through that data and ask us, do we really want to apply that? Which will go out and provision the cloud resources. Oh, that's interesting. And now we wait. This will take about 3 minutes to provision the resources on the cloud. And while we're waiting, I'll go over some of the reasons of why did we choose to use Terraform and Cloud Init. We looked at some of the tools that were already out there, like COPS, for example. But one of the reasons we chose not to use COPS was because we were doing this for the use case of a CI system, which means that we wanted to be able to have these immutable artifacts that after a provision had run and we'd tested this cluster, we could bring it up later, where with COPS, it generates a lot of data on the fly, so it's hard to go back. We can't just have, say, a immutable artifact that we store in our repository somewhere and go, let's use this artifact that was built 5 months ago and expect the same result. And I'm running this twice because there's a Terraform dependency issue that we have with a cloud provider integration at the moment, which means it tries to create a subnet and a new resource after that before it actually creates it. So it needs to be run twice, but if you specify the individual resource with a wrapper, then it doesn't have this problem. So here you can see that it just created the master resource, the VMs, and then the section down here is adding Etsy records. And the reason we're doing that is it's allowing us to generate DNS compatible names on the fly based on the resources we create. So that way we can generate certificates before we actually have the VMs, which helps a lot. And especially when you're wanting to bring up artifacts that were built in the past and expect them to still work. Because if you're going, well, I know the IP of my VMs, I'll use that, you're never going to have those IPs again.
The DNS names or anything.
So now the resource is up. If we go to this data directory, this is the data we got out, and here we have a generated kubeconfig that will let us authenticate with our cluster. So we can set that. And now we won't have any nodes yet because we need to actually add some RBAC roles to make sure our worker nodes can actually join. And in this we have an API server kubelet permission. The worker node's kubelet daemon is secured with RBAC authorization. And then we also have TLS bootstrapping for the worker nodes. So we can actually not know anything about the worker nodes and actually bring them up and have them securely join the cluster. And now we should be able to watch our nodes and see them come up eventually. And we see one here already joined. And then very shortly this should join in the ready state. And then from them we could go on and run our Kubernetes conformance tests, which we do on our CI system. And then if the cluster succeeds, we then go and run additional testing, like we'll deploy Prometheus on that cluster and say, is Prometheus working? So that's the demo portion.
Great.
Taylor?
So that was allocating the resources, all that, deploying vanilla Kubernetes again that we pull down, that we can validate with test. Maybe we've talked about pulling information from test grid or other places to see, do we want to actually do this? Then run our own test after the fact. We can also enable specific flags or plug in different versions of components that go with Kubernetes. So Terraform, as we just saw, cloud in it as well, is passed in, and the manifests are laid down for the vanilla Kubernetes. And that's the main technology for this. Talked a little bit about some of the others, COPS and stuff. I think I'll just hold off on this, and maybe if folks have specific questions on why didn't we use X, then we can get into that in the Q&A. Did a little bit of the code walkthrough. That's over here again under the cross-cloud CI project, the cross-cloud component itself. And this is the GCE module that he was looking at. You can see here the other providers that we're currently supporting: AWS, Azure, GCE, GKE, IBM Cloud. Scroll down. We also have OpenStack Packet for bare metal. Anything else you want to point out right now on this? Kind of went through a bit of it during the code demo. Let's go back over here then. So, I may come back to how to collaborate. I think I'll jump right to the Q&A, and then we can maybe come back through. I don't think we have a mic. No mic, okay. So, any questions?
So, would you recommend us as a Kubernetes user to use your modules and manifests to deploy our Kubernetes clusters in various cloud providers?
So the question is, as an end user, would you recommend using the cross-cloud for deploying Kubernetes and with those manifest? I would say it depends on the use case. So this was designed based on CI. We're not doing long-term management of a cluster, production clusters that are running and you're wanting to push updates and other stuff like that. It's something that could be built into that, but it depends on your use case.
And one of the big things you'll find, especially with tools that are there, that are designed for maintaining production-grade clusters, is that they support your upgrades, rollbacks, and this is from the perspective of we bring it up and we destroy it. We bring it up and we destroy it. We're not trying to keep it around, and it's optimized to be, let's bring this up as fast as possible. We want it out within 2 or 3 minutes, where production clusters probably come up a little bit slower.
What's the test coverage for the upgrade path?
The question is, what's the test coverage for the upgrade path?
We're not running conformance tests for upgrades at this point. We're just focusing on the actual specific release, whether it's being, let's do a build of what master is right now and do a test for that, or let's do a build of the 1.9.3 release and do a test for that.
I've worked with the code quite a bit, and it's nice for bringing up multi-node clusters, play around with it, because it takes care of a lot of things for you. But if something goes wrong, Terraform can sometimes become wedged, and then you have to manually kind of go and clean things up and handle it. So I use it. I actually like it. I think it's a great tool for demonstrating and like showing things off. And I'm not sure I would manage a cluster across cloud, but it's good code. It's not a, as I said, it's not a production install. It's not a long-term maintenance solution.
The only place I could see for like a production is if you have, if your production deployment style is we spin it up, we don't touch it, we blow it away. So if you're already set with that, which whatever tools and technology in the background, if you're already set for that sort of thing, then that might work. Most production, large scale that I've seen, don't do that. They aim for that, but you're going to have some pieces that are sitting around. But if you can, then it's great. And then especially demos and for the CI and spinning up and quick tests, it's really good.
The reason I'm asking is, and nobody else has questions, okay?
Nobody else. It's just.
So the reason I'm asking is that I see a lot of cases where Kubernetes clusters are treated as pets, not as cattle.
Yes.
And I come from a test automation kind of perspective, so it has to be tested, automated, and test-driven developed. That's why, for me, this would be kind of the native approach to automate also the various upgrade paths to make sure that they work really reliably. And then, if you automate that as part of your test coverage, then I don't see why the same tooling couldn't be used for production maintenance.
So I think maybe I can answer that a little bit. It's just not part of the conformance tests, and that's what these tests are running right now. There are automated upgrade tests and rollback tests for in the Kubernetes and test suite, and I assume that this could be extended fairly easily to run different tests than the conformance tests.
Yeah, correct.
Absolutely. So for
It could certainly be extended for that use case. It's just not what the goal right now. But I wonder if you could step back and just talk more about the goals of the project. I think there are 55 certified Kubernetes providers right now.
yeah.
The goal to get every single one of those and do all of the tools that you depend on work on every single one of those.
Okay, so the question was more on goals and are we wanting to support all the different service providers that Kubernetes is targeting, and then some comments about the test coverage. As can we add more? So, Cross Cloud CI, the project, has goals for supporting a lot of different testing, including profiles. So we could say we're doing large clusters or storage-specific pieces. We do a lot of that. We've deploy applications as part of the cross-cloud CI. So we'll deploy ONAP and then run end-to-end test. We've hit bugs in Kubernetes with storage that we see, like open issues and stuff like that. So it's end-to-end testing. The cross-cloud component itself, all of the testing is optional, so you could plug in anything. So you could do the upgrades and stuff like that. The goals are definitely to be a complement to those type of production deploys and keep it as slim as possible to fit in as like a component that you could say, we run this and we can do a large set of coverage. And then for our, when it hits production, if you needed, we do a very specific where it runs like a 2-day or 1 week long running test. That's going to be a different type of setup. Let's see. Did I get all those?
Terraform, for example, and the 55.
Yeah. So right now, as far as like covering all of those providers, we're not actively trying to do it, I guess, as a project, but we're open to it. We've had a lot of feedback of adding cloud providers and stuff that aren't supported by anything else, and so OpenStack was added. 98% just done outside, and we have Oracle coming up, similar. So that support would be, we want to make it easy for anyone else to add support and use it for use cases like, I think, test-driven deployments is a great way to look at that. We're not going to say we're going to just cover it all. I think it's fitting that middle ground and really focused on end users that are not going to say, give me, service provider, just give me this, I'm going to trust this. Whatever you have, I'm going to make it work on one service provider or two service provider. This is really looking at end users that want their own thing, and they need to say, I can understand it at this base level and then build on that. And those type of users, something simpler that's community maintained, where the Terraform side, so they can handle all of the provisioning and see how Kubernetes is installed. It works really well for that. And even if you want to add new modules, so you say, we have our own cloud, and maybe it's OpenStack based, so you could say, I'm going to fork this, and we're going to put all the specific things we need, like to get into this private VPN, whatever. You could do that sort of thing. Real easy from here. Expand on that. And then you would tie back in to all of the testing that's happening in Kubernetes. I think you had a question?
Yeah, I had a question about OpenStack.
Okay.
You saw the demo of the HP. What about
What about
other?
what?
What about other hardware providers? So I can answer for OpenStack. We partnered with one of our public clouds, and so just like you run it on GCP or for AWS, we use those particular cloud provider credentials and run it just like they would run anything else. It's Terraform init, and it builds the code. There's and all the code is actually pretty easy to follow. If you want to see, so if you want to bring, and all the providers, if you go through all the provider directories, they have instructions like, you want to run this on, Azure. This is how you do it on Azure. Okay. Everyone has provider there.
Yes, so the OpenStack, I think if I heard right, the question was about adding other hardware support or OpenStack on other,
Like
your own private?
in case of having an OpenStack like on premise.
Okay, right. Private OpenStack, lesser, yes. So I think using this public one, which is a public OpenStack hosting provider, it's a pretty standard stack. And going through here and looking what that is, it may fit immediately, or it may be something where it would be extended a little bit. Thanks. Any other questions?
Can you talk some more about the CI part of the process, how you trigger that to run as part of CI? It's an important part of the talk title and what people are interested in.
Yeah, sure. So the question is, can we talk more about the CI portion of this?
Yeah, sure. So actually, you might want to go to the dashboard and we can bring that up. So this dashboard shows the component we were just talking about makes up this Kubernetes row here. And we have this section here, the build status. And what this is the status of could we compile Kubernetes from source for the associated release. Here we have v1.10, and this actually goes to the Git commit that was last made. And then we can click here, and this will actually take us to the console out of the build. And we can scroll down, and we can see that this actually took me to the compile job. Yep, this is a compile job. So if we scroll down here, so here we have the build, and we use build release.shell, and that runs through, compiles the Kubernetes binaries, and then packages them as Docker containers, and we create this release file, which points to the artifact. And it's stored under the job ID, and has a path. And this is where, in that input file, I can actually go to that. And if we go to the code we were using just before, GCE, and jump into input, and this section down here, kubelet artifact, kube API server artifact, controller manager, scheduler, and proxy, these are just defaults. And basically, when that release env file is sourced, it overrides these with the versions that we build. And then it runs across to these stages where we actually run that provisioning I ran before, and it goes through, provisions the cloud resources, and then down the bottom, we have the cluster coming up, it's ready, and then we install Helm, which we can then use to create other projects on, or deploy the conformance tests and run through those and report the results back somewhere. And then the next section we go through once those are up is we start deploying these other projects on top of those clusters and running their upstream tests that are available. So for example, we've got ONAP down here. And if we run through this job, we can see that we deployed, and now it's running through their cd.shell, which waits for the project to come up. And ONAP takes a long time to come up because there's a lot of moving parts. And when it does come up, it runs through their end-to-end tests, and here we see that it passed that section, and the job succeeded, and then we get returned a success status on the dashboard.
So behind this, the dashboard is a API server, status repository is what we call it, and that pulls the data from the different CI systems on the back end, and can both pull and push, have info pushed into it, and then you can pull the data, which is pulled onto this dashboard. The dashboard's configurable, can show different projects, and the information available on the screen, of course, is going to be you're not going to be able to display as much as what you can have in the status repository. Right now, this is the overview screen, and we have some other screens like mocked and stuff for doing project screens. We're wanting to gather some more feedback on this before we move forward at this point, but we may end up with a provisioning specific screen that's just about Kubernetes and may have stuff like Rook and some other pieces that are just on that layer versus things that will run on Kubernetes and don't care what provider and what the underlying infrastructure is. The project-specific pages like Kubernetes are likely going to be showing multiple stable versions, and then via the API server we can pull and show the different runs. So we can say, here's the builds and here's how it worked on AWS for the past 3 months. And you can gather all that info and drill down in as far as the UI. The API server itself is public right now. Querying for filters and stuff like that is what we're going to be adding. So for folks who want to hit the API directly and pull that data in, then that's going to be available. And then we're trying to work with different SIGs to see what would be good for pushing data or pulling data. We may be pulling directly from Test Grid. We're talking with Aaron and some other folks about going and saying, here's a new release, and here's some test info, and then potentially saying, here's a check mark, it passed all the test grid, here's what we ran, and what it passed there, and you could gather all that sort of info. And we're going to continue to collaborate there. Did that answer some of your questions as far as on CI? Great.
Yeah, that's super helpful. Thank you.
Any other questions?
So I was wondering, you have ONAP on that list, but it's not a CNCF project. Can you elaborate what is being tested there?
Yes, absolutely. So cross-cloud CI project is, we're trying to make it where it could be used for any project. And the original target was try to support as many of the CNCF projects as made sense, and then Linux Foundation, so this would be the first Linux Foundation project. We're trying to make it available and useful for anyone outside. So whether that's the specific thing like cross-cloud, which is for provisioning, or if you're interested in using the whole CI system, the dashboard, what cloud providers you specify that you want to use is configurable, what projects are there, that's all configurable. It could be used for anything. This dashboard is specific to CNCF. ONAP, though, specific. So ONAP, this was kind of a starter, how to get going with them. If we support, it looks like we will, and if we continue to support more ONAP, they may end up with their own dashboard because there's so many components in that. Right now we're using the service orchestrator as kind of a test for here's how it could work. They've been working to get everything on Kubernetes, putting all of their install stuff and getting it all. The Helm charts have been a moving target. In fact, we're like a forked version that we keep updating. But this is service orchestrator component from ONAP, and the different little pieces, logging, database, and some other parts that are required to run that. So it's not doing like full test with devices or anything else for ONAP yet. Any other questions? How can you add new projects?
So if we go here, and cross-cloud CI, you'll see there's these repositories called core DNS-configuration, and there's Kubernetes-configuration. These are the declaration for building the projects from source. So if we say, look at the Kubernetes one, and in this repository, here is the .gitlab CI YAML file. We actually had a bit of a battle with GitLab with this one because GitLab expects this YAML file to be in the repository to do the CI pipeline, but we want to use the commits from upstream. So the only way to get the file in is to commit it in. And that's not possible, otherwise then we create hashes that don't match upstream. So we had to work on a patch that lets us use a YAML file over HTTP. So in this file you have the stages declaration, build, what do we want to build, package, how do we package it, and that normally correlates to getting the binaries we built and then packaging them in the Docker container. So here we do some choosing here based on which configuration to choose. Based on our environment, we have dev and staging environments as well. And then we have our compile. So this goes through, sets some registry variables, installs dependencies that we need to build Kubernetes from source. And then we run on line 51 the build release, which goes through, compiles Kubernetes. And then we have 64 that specifies that we should store what we just built as artifacts so we can reference them later. And then the second job here is actually pushing the Docker containers that were also published to a registry so we can grab them later. And then generating a release file that we use to tell the cross-cloud provisioner what artifacts it should use when it provisions. And then there's one here for CordiNS, as well as all the other projects on the dashboard, which look very similar and go through the same stages: build, package, and then we should push the image.
I think your other question, as far as adding new projects, so the configuration, if you have access to the repo, you could add a GitLab CI YAML, or as far as, and this is the runner GitLab. We're actually looking to support different type of runner workers. Anything that could have the configuration to run those. And the actual deployment of apps is part of the cross project. So this is what does the Helm deploys of the apps and everything. I think we may be on time here. Do we have time for one more question, or? Yeah, sure. Okay. Did you have a question? No? Okay. Any more questions? Nope. Okay. So we're part of the CI working group, and that's once monthly at this point. There's a mailing list. There's also on the CNCF Slack, there's a cross-cloud or CNCF CI and some other channels that were there. GitHub, Twitter. Love to have some feedback. We're going to be working on the API. What would you like to consume if you're wanting to be able to push and share data? We're trying to look at how to make that open and easy to use. And that's it. Thank you.